what we are looking at today is logarithm laws. So yesterday and the day before we looked at what logs are and how they are the inverse operation of exponential functions. What we're looking at today is logarithm laws. So because logarithms are just another way of writing exponentials, which are indices or powers, there are logarithm laws that correspond to our index laws. So we have our log laws. You have to remember these log laws. None of them are on your reference sheet. I will double check that in a second, but I believe none of them are on your reference sheet. Our first one here is when we have log base A of x times y, it equals log base A of x plus log base A of y. Now that responds, because we have x times y here, and we have an x plus a y. So it corresponds to our index law of a to the x times a to the y, which equals a to the power of x plus y. Okay, so when we have times, it means plus, exactly like our index law. When we have division, it means we're minusing our logs. So log base A of x divided by y, and remember divided is the same as a fraction, is equal to log base A of x minus log base A of y. So that corresponds to the index law of a to the power of x divided by a to the power of y, which equals a to the power of x minus y. Okay, so when you have two logs minus together, it means that together it's division. When you have two logs added together with the same base, it means that it's multiplication. Okay, so multiplication and addition, division and subtraction go together. The other two log laws that we have is when we have log base A of x to the power of n, the power of n comes out the front and we get n log base A of x. So the reasoning behind this is if we have log base A of x plus log base A of x, because when we add two logs together, we multiply the x's, so we get x squared, okay? But log base A of x plus log base A of x, we have two of the same thing, so we have two lots of log base A of x equals our log base A of x squared. Okay, so that is our reasoning behind that log law. Our last log law is when we have log base A of 1 divided by x, it equals negative log base A of x. So with this log law, what we have is we have that log base A of 1 over x. Another way of writing 1 over x is x to the power of 1, because we have 1 over x equals x to the power of 1 from our index laws, okay? And then we use that law from up above, that blue law there, to bring our power out the front, okay? So whenever we have something to a power, the power comes out the front. Now, these four log laws are something that you need to remember and know how to use. For our examples, what we have is, our first example is given that log base 5 of 3 equals 0.68 and log base 5 of 4 equals 0.86, we want to find the following. So what we have is we have that log base 5 of 12 is the first thing we want to find. So that is the same as writing out log base 5. How do we get 12 from 3 and 4? Times, right? So that's the same as log base 5 of 3 times 4. So we're going to be using that yellow law, okay? So the multiplication law. And that law states that we have log base A of xy equals log base A of x plus log base A of y. That is the law that we are going to be using. So what we have is we have that log base a of 12 will equal our log base a of 3 plus log base a of 4. Oh, sorry, the a's are meant to be 5s. My bad. Sorry. Okay, now from our question, we know that log base 5 of 3 is 0.68, but that's a bad colour, isn't it? I'm just going to repeat colours. I'll do pink and I'll do green, because pink and green look okay, don't they? Yeah. So we know that log base 5 of 3 is equal to 0.68. And then we know that log base 5 of 4 is equal to 0.86. So then we can just simply add those two decimals together to get that. Therefore, log base 5 of 12 is equal to 1.54. Does that make sense? So we're just using that property and that law from up above. Okay. The next one that we have is B. And B says that log base 5 of 9 is what we want to find the value of. How can we manipulate 3 or 4 to get 9? 3 squared, right, is 9. So this is going to equal log base 5 of 3 squared. So which law are we going to use? Our blue law. So what we have is that log base a of x to the power of n is equal to n log base a of x. That's the law that we're going to be using. So what we have is that log of base 5 of 9 is equal to log base 5 of 3 squared. Now, what happens with that squared is it's our n value, and our n value, or our power, comes down the front. So we'll have 2 times log base 5 of 3. Now, we know that log base 5 of 3 is equal to the decimal of 0.68. So we just need to go 2 times 0.68 to get us the answer of 1.36. Does that make sense? Silence means yes, I guess, unless somebody speaks up. Okay, the next one is log base 5 of 0.75. How can we get 0.75 from 3 and 4? It's a fraction, right? So it's going to be the fraction log base 5 of 3 quarters, because 3 quarters is the decimal 0.75. So we're going to be using our green law for this question. So we will have log base a of x on y is equal to log base a of x minus log base a of y. Okay, so in our question, we have log base a of 0.75 is equal to our log base 5 of 3 quarters Okay, so we can use that law and we will have log base 5 of 3 minus log base 5 of 4. Now, we know that log base 5 of 3 is equal to 0.68 minus our log base 5 of 4 is equal to 0.86. So when we put this into our calculator and we subtract our decimals, we get our answer to be negative 0.18. Just rewrite that because my pen. Okay. Now, the last one that we have is log base 5 of 20. Now, how can we get 20 either using our 3, 4, or we can also use our base of 5? How can we use 3, 4, or 5 to make 20? 5 times 4, right? So what we will have is that log base 5 of 4 times 5 is what we're going to be doing. So we're doing our multiplication again. So our multiplication is that yellow law. So we're going to write that out. Our log base A of xy equals log base A of x plus our log base A of y. What we then need to do is we have log base 5 of 20 is equal to log base 5 of 4 times 5. So we will have log base 5 of 4 plus log base 5 of 5. Now, we know that log base 5 of 4 is equal to 0.86. Now, yesterday we learned a property about when we have log of the base of the answer is just equal to 1. Great job, whoever said that. So, log base 5, I know I'll use orange. I know it doesn't come up well, but I need a different colour. So log base 5 of 5 is equal to 1 because of that log law. Log base A of A is equal to 1, which is what we looked at yesterday. So when we add those decimals together, we're going to get 1.86. Okay. Hopefully that makes sense. Once you've got that copied down, turn to the next page for me, please. Okay, so we're using those properties for our next set of questions as well. So in our next question, what we have is we have to solve log base 2 of 12 equals log base 2 of 3 plus log base 2 of x. Now, this is written in that yellow property form in our multiplication form. So we're going to copy that out. So we will have our log base A of xy is equal to log base A of x plus log base A of y. Okay, that's in the same form. Now, what we have is we have that log base 2 in this question of 12 is equal to our log base 2 of 3 plus log base 2 of x. That's just rewriting the question. So that means that our log base 2 of 12 is going to equal log base 2 of 3 times x. Now, when we have something with the same log on either side, what we are technically doing is just getting rid of the log base 2. and we're just going to look at our 12 and our 3 times x. Because for these to be equal, our 12 and our 3 times x need to be equal. So what that means is we'll have 12 equals 3x. So using a random colour, I'll just use purple. So 12 and 3 times x, that's what we're now looking at here, okay? And then we are trying to solve. So when we're trying to solve something, we're being asked to find x. So to find x, we just need to divide by 3 to get x equals 4. Yes? Okay. Question 3 is similar. Question 3, we want to simplify log base a of 21 if log base a of 3 equals p and log base a of 7 equals q. So we've been given 2 values. We've been given, or 3 things actually. We've been given log base a of 21, log base a of 3, and log base a of 7. How do they connect? Which law do they connect to? The first one, the multiplication law, right? So we're going to write that law down. So we're going to write down our log base a of xy equals our log base a of x plus our log base a of y. So what we will have is that log base a of 21 is going to equal log base a of 3 plus our log base a of 7. Now we're being asked to simplify this. So we're trying to find an expression for our log base a of 21 because we know that log base a of 3 is equivalent to p plus our log base a of 7 equivalent to q. So therefore we have that log base a of 21 is just p plus q in this case. Okay, now our next example is a real life example and how we can use this in real life scenarios. So we have the formula for measuring R, which is the strength of an earthquake on the Richter scale, is the formula R equals log base I over S. So when I say log base I over S, I have a division in there. So because I have a division in there, I need to use my division law is what I'm thinking about for future down the track. This is where we're told that I is the maximum seismograph signal of the earthquake being measured and S is the signal of a standard earthquake. Apparently there was an earthquake in Dubbo the other day or yesterday and the elephants woke up. It was on the news. Anyway, so what we're going to do is we're going to show that log base I equals R plus log base S. So what we have is we have that R is equal to log of I over S. So we need to use our log law that goes with our division. So our log law with our division is our log base A of X on Y is equal to our log base A of X minus our log base A of Y. That is the law that we are using for this question. So what this means is we will have R equals, instead of log I on S, we will have log of I minus log of S. Now, have we shown that log of I equals R plus log of S? No, because we haven't made log of I the subject. So to make log of I the subject, we just have to add log of S to the other side. So we get log of I is equal to r plus log of s. Little therefore in front of it because we have shown what we've been asked to do. Okay, now what we get to do is we have I equals s 10 to the power of r. We are going to start off with the formula from the question. R equals log. When I have log, what's my base? 10. So we have log of base 10 of our I on s. Now, so we have a logarithm. What are we trying to get to in our show that? Starts with an E, an exponential. So what we need to do, if we're going from a log to an exponential, we need to do log map. Great. So we have log base answer equals power converts to base power equals answer. How exciting. All right. So our base is 10 in this question. We have our power is R. And we have our answer is our I on S. So we can put that in our log-back conversion calculator in our brains to get 10 to the power of R is equal to I over S. What are we trying to make the subject? I. So to make I the subject, we need to multiply by S to therefore get we're trying to make I the subject. Whoopsies. Having too much fun. I equals S times 10 to the power of R, which we can write as S bracket 10 to the power of R. So when we have anything in brackets, it just means we're timesing. Yippee. All right. The last thing I need to teach you is on our reference sheet. And it's also a little bit redundant if you have the new calculator. But if you don't have the new calculator, this is very important for you. So we need to be able to change the base. So everyone with the new calculator has the log button on their calculator. And we can just evaluate. Blake, I really need you to listen. We can evaluate log base 5 of 2 correct to 2 decimal places just by using our calculator, right? If we have the new one. However, the old calculators didn't have that function, so we have this change of base formula. It's still important to know it. It's still on our reference sheet, so it's an important thing to know. So if we need to evaluate a logarithm, we use this change of base formula. So this change of base formula is on our reference sheet. Okay, now, it doesn't matter whether we use log base 10 or log base E, so our ln button on our calculator when we do this as well. We're going to get the correct answer as long as we use the same one. So, our formula that we're using is log base A of x is equal to log base B of x over log base B of A. So what that means is B is either going to be 10 or E. It doesn't matter what you use. Okay, our A value is our base. It goes on our bottom for base. Our X value, it is big, so it goes on our numerator. So what we will have is to evaluate log base 5 of 2. It will equal log of 2 over log of 5. So we put our big number on the top and our base number on the bottom. Yes, but that might be the other way around. You might be trying to find log base 2 of 5, right? But the big number in terms of like size when we draw it. So what we can do is on your calculators, you're going to press log 2 divided by log 5 for me. You should get 0.430676 ... Now, if you pressed ln2 over ln5, you'd also get the same thing. And so therefore, we get that log base 5 of 2 is equal to 0.43 to 2 decimal places. Now, if you also press that new button on our calculator, you should get 0.43 to 2 decimal places. All right, I want you guys to use the change of base formula to work out number 6 for me. First things first, you should write out the reference sheet formula for me. I know our calculators now support us to doing this, okay, but it's important that you still know how to do it, because your calculator might die in the exam and you might have your old one there as backup and you might need to have to use that, okay, and it doesn't have the button. So we'll have log base 2 of 3 equals, I'm going to use ln for this one just to show you that it doesn't matter what you use. Also, ln is funner because it's only 2 letters that you have to write down instead of 3 for log. Saves so much time. Funner, yep. Alrighty. Has anyone put that in the calculator for me yet? We get 1.58496 ... So to 1 decimal place for this question, it is 1.6.